Hello and welcome to today's webinar, The Next Big Thing, Understanding Container Platforms and the Puzzle of Application Modernization. My name is David Davis of Actual Tech Media, and I'm excited to be your moderator for today's event. This event is brought to you by Hewlett Packard Enterprise with special guests from ESG, the Enterprise Strategy Group. Before we get started, we have a little bit of housekeeping here that we first need to cover. We want this to be a very educational webinar, so we encourage you to use the questions box in the audience console there, just to the right of where it says handouts. You can see questions. If you click on that tab, it's there that you can enter your questions about today's topic. We'll be doing a dedicated Q&A session at the end of the webinar, so get your questions in early, and we'll be prioritizing the best questions for that Q&A session. So we encourage questions. Also, I want to call your attention to the Handouts tab there, and you can download the full slide deck from today's presentation in the Handouts tab. So just click on that. It will download the PDF to your local computer, and you can read it after the event. I encourage you to do that now because that slide deck won't be easily accessible after today's event concludes. And then finally, at the end of today's webinar, we'll be awarding an Amazon $300 gift card to one lucky attendee on the live event. If you're watching this on demand, I'm sorry, the drawing has already occurred. The prize terms and conditions can be found at events.actualtechmedia.com. And with that, I'm excited to introduce you to today's presenters. They are Mr. Tom Phelan, HPE Fellow, Office of the CTO for Hybrid IT at Hewlett Packard Enterprise, and Mr. Bob Laliberte, Practice Director and Senior Analyst at ESG. Tom and Bob, thank you so much for being on the event today.
Thank you.
Thanks, David. Happy to be here.
Excellent. Well, really special presentation lined up for you today. It's a topic that I find very fascinating and very cool and innovative, cutting edge stuff today. So with that, I'll hand it over to our first presenter. Bob, take it away.
Awesome. Thanks very much, David. Hey, I thought we'd get started by taking maybe a little bit of a big picture look to see what's driving a lot of these organizations to change. And obviously, for a lot of those organizations, that's really about digital transformation. So to give you some context, this data is from ESG's annual technology spending intention survey. And we polled about 658 IT decision makers across North America and Western Europe, working at both mid-market and enterprises. And what we found was that organizations are continuing to mature their digital transformation initiatives. And in fact, what we found that the key takeaway here is that almost 20% of organizations now have mature digital transformation initiatives. And another almost 60% are in process or beginning, and the remainder are starting to plan for it. Now, we find this is really important because that tends to follow that traditional maturity model of 20% being the early adopters, 60% being the followers, and the remaining 20% being the more conservative adopters. And the reason why we like looking at this data is it's really important to learn from those early adopters. So throughout my presentation, I'll try and highlight some of those differences where we observed it from those early adopters. And it's also important to remember that the digital transformation is about people, process, and technology. Now, in addition to learning about where they were in their digital transformation maturity, we also wanted to find out what were the top goals? Why were they doing this? And really what they came back with, the top two responses I thought was critical to report is they really wanted to find out how they could become more operationally efficient and how do they provide a better and more differentiated customer experience. So it's been interesting. We've been asking this question for a couple of years, and it was really interesting to see the jump from last year to this year, and the customer experience jumped up significantly. And if it continues on that same trajectory, it's going to be the #1 goal for next year. So this is obviously these two things that you think about here, these two goals. It's really one of the biggest areas that organizations are trying to drive, and it's really important to the application environment as well. And so in addition to that research I just told you about, the rest of the data coming from me today will be about another survey that we conducted last fall with about 200 enterprises and mid-market organizations, specifically around their container environments. And that's where this data point comes from. I don't think it's going to be a surprise to any of you that all organizations want to move faster and they want to become more operationally efficient. The fact that 86% of organizations reported being under pressure to launch new apps and services really highlights the need for newer technologies and processes to help organizations deliver a better service, right? It's also, I think, indicative of the need for I think for organizations to be able to respond to a demanding customer base, and the fact that the market environment is really driving organizations to respond quickly, and there's real value to those organizations that can deliver first to market advantages. The key part of this is that I think it's really important to remember it's not just about launching new apps and services quickly, but it's about being able to do so in a secure, scalable manner while making sure that you've got the requisite performance and availability levels, and not just on day one, but for the entire life cycle of that application. So I thought maybe at this point it would be worthwhile to take a few minutes and get some context on how we see how application environments have evolved. And really, I think the key part of this is we need to break it down and look at the different development processes, the application architectures, the deployment models, excuse me, and the underlying infrastructure that's been used for all of these different application environments. So as I build out the slide, I assume most of you are going to be familiar with these terms, and many of you will have a lot of experience using some of these at some point in your career. That may vary depending on if you're cloud native, digital native organization, and a lot newer, but we'll see as we go. So to start off with, and this is the earlier models, maybe you might even at this point refer to them as legacy environments. They're typically characterized by having these monolithic application architectures and the time-consuming waterfall processes for development that didn't really lend themselves to rapid updates or any kind of fixes or patches to existing software. And it was common for these, when we're developing new applications, to take a really long time to develop, right? Maybe even years to do so. So these applications tended to reside on physical servers that were residing in corporate data centers. And they tended to be something where there was an update to them, maybe one major release a year, and then possibly there was one or two minor releases a year as a common practice. So organizations really, they realized that they needed to streamline the application development. And there was a lot of time and effort put into developing agile processes, right? This is where the scrums were started and so forth. So those were adopted, and they started taking advantage of service-oriented or multi-tier, N-tier architectures. And from a technology perspective, this also coincided with organizations adopting virtual machines. And they created obviously a much more dynamic environment, which also helped to accelerate these deployment times and also maybe help promote faster and more frequent application releases as well. Moving forward to where we are today, you'll see that a lot of the modern applications are built around using microservices architectures. And that really breaks those applications down into much smaller, much more manageable pieces. Now, these are often referred to as cloud native applications, and typically they're going to leverage containers to deliver even greater levels of flexibility and agility. So if VMs were defined, if that environment was defined as being able to support dynamic environments, you need to think of containers really as being able to support ephemeral environments, where services are spun up and retired in just a few seconds, right? So a much different environment, much more agile. And when you combine that with the DevOps process, these cloud native technologies can significantly accelerate the application lifecycle. So while microservices and containers enable development teams to iterate the application updates and new functionality at a faster pace, the DevOps practices really helps to ensure that the software developers and IT operations teams are tightly integrated to optimize application delivery into those production environments. And with these modern technologies and processes, the business ultimately benefits because it's a lot more responsive to those changing market conditions and with dramatically improved product quality. And I think the other important key takeaway here is that While the public cloud has played an integral role in this new era of cloud native development, it should be noted that cloud native does not always mean public cloud only. And as you will see, I think, there's a lot of organizations that want to deploy these cloud native applications in the on-premises locations as well. So let's take a look at where some of your peers are on this journey to evolve their application environments. And we'll get started with talking about the transition to DevOps environments. So according to our research, organizations are now picking up the DevOps methodologies at a pretty good pace. And as you can see here from the research that we conducted last fall, that organizations running containers or planning to run containers in production, you can see here that 66%, right, almost double of what the overall reported, are now using DevOps extensively as compared to that overall group. So the other area we wanted to look at was around application architectures. So how did these application architectures change as well? And this demonstrates again how rapidly change is taking place in these application environments. You can see on the lower left side of the pie chart that when we asked organizations about what architectures they were leveraging for new application deployments, microservices led the charge with 38%. Okay. It's important, however, to note that, again, depending on your organization, there's still going to be a mix of basically all of these different application types. And in fact, 20% said they're going to decide on a case-by-case basis as to what type of application architecture they're going to use. So just be aware that you're going to be dealing with a mix of application architectures for some time. Now, again, if we look at this data as it's split up by digital transformation maturity, again, very interesting to note that 50% of organizations say they'll go to a microservices architecture for new applications. All right. So again, seeing that difference of organizations who are more mature, being able to look at leveraging these new technologies, these new processes a lot more. So next, we want to take a look at container adoption. But before we do that, we thought perhaps we should take some time to discuss what containers actually are, how they compare to other technologies. And to do that, I'm going to turn the presentation back over to Tom.
Thanks, Bob. That was really informative in helping set the stage for how we do app modernization. So what Bob has told us here in the last few slides is, we have two different types of applications, at least two different types. We have legacy applications, and we have these new kind of fluid, modern, cloud native applications. And we walked through the evolution. How did we get here? We had physical servers, then we had virtual machines, and now we have containers. Let's take a step back for a moment and see what the value propositions for each of these technologies. So a container, everyone knows what a container is. It's something that holds something else, perhaps for transportation purposes, perhaps for the ability to control what is in this group of information stored in this container. This is precisely what we mean when we talk about computing and containers. A container is a software construct that allows us to package and deploy applications quickly. What is interesting about this is that we include all the dependencies in that container specification. So if the application requires certain versions of libraries or certain configuration information, that information is bundled along with the software itself in the container definition. How does this differ from a virtual machine? Let's drill down just a little bit on that. With a container, we have these little packages which contain not only the application, but also the libraries. In this slide, what I'm showing is the Docker engine. Docker is one very common runtime for running a container. There are others, but we'll settle on Docker for this discussion here. Altogether, each one of these packages of applications running on top of the Docker engine share the host operating system. The operating system is the software itself, which communicates with the underlying memory, CPU, storage, and networking of the underlying physical or virtual infrastructure itself. What we'll notice here is that these applications share a great deal of the infrastructure. They share the Docker engine and they share the host operating system. This is distinctly different from the technology of a virtual machine, where a virtual machine, as we evolved from physical hosts to virtual machines in the late 90s and early 2000s, it was a direct lift and shift. What a virtual machine was, it was basically a replica in software of the hardware itself. So each one of the virtual machines has a guest operating system and essentially believes it's running on physical hardware. This is what made it so easy to migrate applications from physical servers to virtual machines. They didn't need any re-architecture since the virtual machine provided all the abstraction for them. As we move to containers, we see that in order to get the flexibility, speed, agility of containers, we have to give up some of that virtualization, cloud, or abstraction. And the benefit of that is the containers are lighter weight and they can come up more quickly. So what we benefit from containers is a sense of portability. There are no dependencies on operating systems because the operating system is outside of the container virtualization envelope. They have a much smaller footprint. This means you can do bin packing, you can run more application software on the same unit of physical infrastructure when you're using container abstraction than what you would be able to do with virtual machines themselves. Infinite scalability. What this means effectively, nothing's infinite, but when we say infinite scalability, there is no architectural limitation to how horizontally scalable an application can be. This is extremely important when we're talking about DevOps and new cloud native solutions. How can we scale them horizontally so that they can respond to the demands of the customers themselves, or the individual users? And finally, what Bob spoke about was the speed. The rapidity at which a container can be instantiated is orders of magnitude lower than what it takes to start a virtual machine. So an application can be started very quickly, and because it can be started so quickly, it can be torn down and those resources freed up for other applications to use. Since we have this, we will see that, oh, now we have this new technology. Applications themselves started to evolve to take advantage of these aspects of the containers. And as we go through the rest of this webinar, we'll talk a little bit about that evolution. So how we went from legacy applications to cloud native format. Now I've brought up some new terminology and I'll introduce a new one here on this slide as well. We've spoken about Docker containers. So Docker is a company, they revolutionized the industry by open sourcing a file format which allowed us to easily describe the contents of a container. So previous containers existed, they were known by a number of different names, but there was no real easy way to define the contents of a container. Docker file format allowed us to do that. And with that, then this became a de facto standard. Every enterprise and every hyperscaler public cloud understood and would be able to support the Docker file format. Now that was great. That allowed us to specify an application in a standardized format. What we needed next was a way to easily deploy that Dockerized application onto our infrastructure. And what has evolved over the last 8 to 10 years is the Kubernetes open source container orchestrator. You may have heard other things like Docker Swarm or Mesos. There were a number of other earlier container orchestrators, but they never really got the open source drive and traction that Kubernetes has. So what Kubernetes now is a de facto API standard for deploying Docker containers. These two things make it extremely easy for the customer to define their application deployment once in a Docker container file, and then deploy it on any vendor's hardware or software, public or private or edge. So this what makes it really flexible and powerful for a customer to say, hey, I want to deploy some of my application instances on premise. I want to deploy some of them in the public cloud, and I want to deploy other ones on low power, low ability edge nodes. And I want them to make sure they're running all exactly the same software, and I want to be able to update them frequently. With these two technologies, a container definition and a container orchestrator, the customer can do that. It's huge steps forward in the industry. Now let's talk about the two types of applications that Bob brought up earlier. We have legacy applications and then cloud native applications. You're asking yourself, well, why on earth did we ever write legacy applications if cloud native applications are so much better? Well, the reason we had to write legacy applications is because originally all we had was an operating system running on physical hardware. So the software architects and developers wrote these applications to run as quickly as they could. And the reason they wanted to run, they knew the software services knew a lot about each other. They knew how they were to expect information transfer. And so they were written in these tightly coupled architectures. And that was done because there was no other way to do it. As we evolved into virtual machines, then finally on into containers, we found out, hey, there is a better way. We now have these technologies where I don't need to tightly couple my software surfaces. I can break them into highly scalable, loosely coupled, independently manageable, really, services that when these services are used together in a cohesive behavior, that then I get my high-level application behavior. That was the evolution in the production of cloud-native apps. But here we are in 2020, and we have a combination of these applications used by every enterprise out there. Some of them have many legacy applications, and it's too expensive or too much effort to re-architect them to cloud native. So we have to run them. We have to find methodologies to run those legacy applications, leveraging what we can of the flexibility, agility, speed, performance of the containerized orchestrators like Kubernetes. And then we have this new set of applications, cloud native, which deploy quickly on Kubernetes and can be infinitely scalable. So here is where we're faced. Technology providers are now helping enterprises run both types of applications. Probably in another 10 or 12 years, there will be no more legacy applications. Everyone will have re-architected the cloud native, and then we can move on. But this is where we are today. And as you make your decisions around what infrastructures to bring into your enterprises, you have to understand that, yes, there will be legacy applications for a period of time, and you want to be able to handle them, but you also want to be able to quickly handle cloud native applications as they evolve. At this point is turn it back to David for a poll. Thank you.
Thank you, Tom. Yeah, really great presentation thus far. I'm learning a lot. I know the audience is as well. I've just brought up a poll for everyone out there that says, what is the current usage of containers in your enterprise? And the options are you're using it in production, using containers for dev test, but plan to use in production in 12 months, or we're not using containers now, but plan to use them in production in 12 months, or we're not using now and we don't have any specific plans to use them right now. So I'll leave that up for just a moment. While you answer that poll, I want to call out this great feedback that came in from Steve. He's attending and he said, this is one of the best webinars I've seen, as it clearly and simply explains the fundamental difference between VMs and containers. So we appreciate that great feedback, and we appreciate the responses to this poll. So let me share the results with you now. And it says that 24% are using containers in production, 13% plan to use them in the next 12 months in production, 21% not using them now, but plan to use in production in 12 months, and 41% have no specific plans. Tom, what's your take on that?
Yeah, hey David, this is Bob. I think I'm gonna jump in here because yeah, so this is really interesting to see. So it's great to see that adoption into production, the 24%. the numbers that we have there for they're using it in dev test, but plan to use it in production over 12 months. And then another 21% saying they don't use it now, but they're planning to. And then another 41% who are just really interested in this and want to understand what's going on, right? Because this is something, while they may not have plans today, as this technology evolves, I'm sure that's going to be something that gets integrated into their environment as well. And what we wanted to do, the reason why we asked this polling question is that ESG asked a very similar question. So now I can show you where some of your peers are. There is one noticeable difference that I want to point out, and that's in the research that we did. Because we wanted to talk to those more advanced organizations, we only talked to organizations that either were using them in production, were using them in dev test and plan to go to production within 12 months, or weren't using but plan to within 12 months. So just the top 3 responders are what we wanted to see. So let me show you what that looks like. And again, the reason we did this is so that we could try and learn from those more advanced users of these container environments to better understand what they were going through. So as you can see in our research, the way it shook out was that 61% of the respondents to our survey said they were deploying containers in production, and 29% said they had deployed it in their dev test environment and they were going to roll that out, and just over 10% said we don't have it anywhere now, but we're going to roll it out into production. So the interesting part here, it's that a lot of these organizations that have been using them have a fair amount of experience with these container environments, right? So if you think about that, it's almost 80% of these organizations have deployed containers in production for over a year. And if we double click down on that, you can see of that 80% over a year, 25% have been running in production for over 2 years, and 16% have been running for over 3 years. So this is really interesting, but I think the other thing that you might be interested in, sounds like fairly high numbers, right? All these containers moving into production. How did that translate into organizations' overall environments, and how big are the container environments today? So we went ahead and we asked that question of organizations, and you can see in this chart, it's really highlighting what percentage of production workloads are hosted on which type of technology today. And we gave them the choices of bare metal, virtual machines, or containers. And you can see, as you would expect, a lot of organizations have the virtual machines, right, the dominant area. But for these organizations, and again, remember, these are the advanced people, right, only people that had containers, you can see that it makes up about 22% of the environment today. But what is interesting, as Tom had mentioned, this environment is going to keep growing. You're going to see more organizations shifting their legacy apps over to these cloud native apps. And what you're seeing is that growth going from 22% to 34% over the next 2 years. So I wanted to put this slide in so you could use these numbers to maybe help benchmark your environment. So for all those organizations said that, yes, we're currently using it in production, getting a feel for where you are in production. As we said, we're still fairly early days with these container environments running in production. But as you can see, it is starting to pick up a lot of steam. There's a lot of momentum. And so organizations need to prepare for that and be ready for that. And then the next question is really around, where are these containers going to be run? As I mentioned earlier, cloud native doesn't always mean public cloud. So to give you a better understanding of where these container environments are going to reside, we asked them where they would deploy their container environments. And as you can see, the respondents overwhelmingly selected that these container environments would be deployed in a hybrid cloud environment. And that was being defined as a combination of private data centers and public cloud environments. It's also interesting to note that those who had cited cloud only did so because of policy and preference, right? i.e., my company has a cloud first policy, so that's where we're going, right? That may be a digital native company, right? Those organizations that are less than 10 years old that want to really focus on the cloud. But what's also interesting, for those organizations that selected hybrid, you could see that they chose it because of the performance, security, and cost factors. So I found this really interesting because ESG had done a survey a couple of years back looking at that boomerang effect, organizations pulling applications down from the cloud and moving them back to on-prem. And the reasons for pulling those applications back were eerily similar to these. It was about performance, it was about security. And the security, it's not that the public cloud's inherently insecure. It's just with shadow IT and those types of things, there were data sensitivity issues, right? There wasn't a cohesive coordination between the developers or the business that were spinning these up and the IT operations teams, right? So those organizations had to pull those back. And when it came to, from a cost perspective, that was largely the mid-market companies. We're saying, hey, we didn't know what we're getting into with this public cloud, and we're finding it really expensive, so we're bringing it back. And then lastly, the takeaway from this is that not only is hybrid cloud important, but so is multi-cloud. And by multi-cloud, what I'm referring to is multi-public clouds. And in our research, when we asked how important it was to have the capability for your container environments to go to multiple public clouds, you can see here that almost 90% felt it was either important or very important to be able to connect to multiple public clouds. So I thought also it would be worthwhile, like I said, I've been making a lot of comments about the fact that we wanted to learn from those organizations who have already deployed. So what did we learn from these guys about their challenges that they faced? And so if you look through this list, and I'm not going to read all of them, but you can see their top challenges around security not being proven and mature. And this probably isn't a surprise either to any of you, certainly not to me. All of our surveys, when we ask about top challenges, top business initiatives, right? Security is a huge part of that in any organization today. So again, the importance of having a secure application environment is paramount for a lot of these organizations. The next part was about scalability. And as Tom mentioned earlier, it's designed for infinite scalability, but I think organizations, when they're first getting started, there's a lot of concerns. And I think a lot of it also might come down to that number 3, which is that lack of container expertise about how do we scale it appropriately, right? How do we scale it on-prem? How do we scale it on-prem into the hybrid cloud environment? So there's a lot of areas around there. And certainly organizations getting up to speed, this happens anytime there's new technology. Organizations are trying to deal with, right? How do you keep the lights on in your legacy environments while developing expertise in these new technologies that are being developed? So obviously, this is an area where, if you're in management and so forth at your company, investing in training courses. And, I think right now, that's probably for most of us, that would be an online training class. But making that investment in these new technologies are absolutely going to pay dividends. So I won't go through the rest of them, but you can see there's other areas around network connectivity, how to ensure compliance and governance, and any reliability. Again, anytime you're moving to a new platform, there's always going to be concerns about that, especially if you're going to be working with the open source versions as well. So we just talked about the challenges. So I thought maybe after going through those, we should talk to you also about what benefits were achieved from these organizations. Why did people do this? What were they getting out of it? And you can see here that off the top of the bat, organizations reported they were getting better application performance. So if you remember my initial slide where we talked about delivering a better customer experience as being one of the top goals for digital transformation, so that ability to ensure optimal application performance is really going to go a long way in providing a better experience for your customers. Also aligned to that is the ability to drive a higher quality software as well, right? So if you have fewer bugs, fewer patches, that's going to result in better experiences for organizations. And application portability is going to be critical, as you can see, because especially with the desire to run in that hybrid multi-cloud environment. So them reporting that, yes, this is much better, I can move my applications around much more easily, is going to be a huge benefit for them. Another area I wanted to pull up, the number 4 slot in DevOps enablement was a top benefit. This was really interesting. When we cut the data by those organizations that had more mature digital transformation initiatives, if you remember, there was a much higher adoption rate. Right, those with the mature higher DX all said that DevOps drove container adoption. However, when I cut the data by those really early container adopters, the ones at 2 or 3 years of experience, they actually reported the opposite. In that case, those companies had the technology, they were deploying containers, and that's what drove their DevOps. They needed a way to communicate between the developers and the IT operations teams to empower them, and it drove that. So very interesting to see that. And also you can see further down the list, organizations being able to accelerate their software development. So I talked about at the start, 86% want to accelerate it. The reality is when we looked at that data about those organizations, the people that had containers in production environments, it was almost 2-to-1 that the ones with containers in production were able to either meet or beat their deadlines for deploying new software. So significant advantages for those organizations. And then lastly, what I just really wanted to cover is taking a look at another area that's important and related to managing these container environments. Tom spoke to the fact that there was, you had Dockers to manage the individual and spin up the individual containers and describe them, and then Kubernetes to help orchestrate and manage that environment. So it's interesting to note that while organizations really want to have a hybrid cloud environment, the ability to manage those applications across both the on-premises and public cloud can create some challenges for organizations. So it's really important to get the appropriate solutions that enable organizations to manage that across both of those environments, whether it be on-premises or in the public cloud. Another important factor to consider here is that as the environment becomes more distributed, it's going to be more complex. So again, having those solutions to manage it, more important. Costs are always an issue for IT, but it's even more important now with organizations trying to dedicate as much of their IT budget as they can to drive their digital transformation initiatives. So the key is, how do you ensure yourself that you're putting as many budget dollars go into that innovation budget and not keeping the lights on and making that shift and balancing that out? We've already talked about skills, so I won't talk about that again. I think that's pretty clear. And then lastly, I think the troubleshooting is going to be a major concern. As we talked about in an always-on environment, it's going to be imperative to find and fix those problems as quickly as possible. So given that one of the reasons cited for deploying hybrid cloud was increased performance, the ability to troubleshoot across that hybrid environment is also going to be extremely important as well. So I want to thank you all for listening to my section. I'm now going to turn it over to David for another polling question.
Thanks, Bob. Great presentation. The next question we have on the screen is, what is your current usage of the Kubernetes Container Orchestrator in your enterprise? And there are three easy answers here. We're using Kubernetes in production, we're using Kubernetes but not in production, or Kuber what? So you're not even familiar with Kubernetes at this point. So I'll give you a few seconds here to answer that poll question, and then I'll share the results. I see a lot of responses coming in already. Thank you for that. All right, let's get just a few more. And thank you everyone for responding to that poll. I'll share the results now. And the results came in here, 54% said Kuber what? They're not sure quite yet what Kubernetes is or how it can help them. 26% though said they're using Kubernetes, most likely in a dev test scenario, and 18% said they are indeed using Kubernetes in production. Tom, what's your take on the results?
Thanks, David. This is really interesting, and it's I'm glad you're tuned in today, because we'll hope to move those numbers a little bit. Very understandable where in the earlier poll, we saw about 41% of enterprises, of people on this call, had not yet adopted a container strategy. And here we see that there are even larger number, 54% approximately, have not looked at Kubernetes as a possible way of helping out. What I hope to provide in the next few slides here is as you would develop your container and your Kubernetes strategies, what to look out for, which will hopefully minimize the risk to your enterprise and provide you with a higher possibility of success as you migrate your applications from their current deployment status into a container and ultimately a Kubernetes environment. So what I want to show here is just recap essentially of what Bob provided in the earlier slides. Is when we're talking about Kubernetes, there are some challenges. So the common question I get all the time is, hey, Kubernetes is an open source solution. It's supported by Google, one of the biggest tech companies in the world. Why can't I just go ahead and install that open source software, and won't it just run for me? Well, that would be a perfect world. But we don't live in a perfect world. So yeah, installing Kubernetes is great for kind of a test and dev and kick the tires type of thing, but installing it at scale is another kettle of fish entirely. And how do I modernize my apps? I have, probably, a normal, typical enterprise will have 1,000 or more, literally, of J2EE applications that they have been running with, for the last 20 years. How do I modernize those apps? How do I deal with this statefulness of my applications? Cloud native applications are not stateful, they're stateless. There's a definite dividing line between the persistent data and the running application itself. How do I deal with that as I try to modernize my applications? And then, as Bob pointed out, one of the critical things with enterprise grade solutions is how do I integrate with my security apparatus within my enterprise? How do I guarantee data security? How do I guarantee that only the right users will get access to the right resources? So all these things are real challenges to bringing Kubernetes and by association containers into the enterprise. So let's go ahead and look at a platform checklist. This is like the first thing you want to do when you start to evaluate platforms and you want to put together your plan, your architecture for running your applications going forward. So you want a tool, a mechanism that supports multiple Kubernetes versions simultaneously. Say, why on earth do I need to do that? I'll just run top of trunk. Well, let's take a look at this. Kubernetes is an open source community, an extremely rapid and fast moving open source community. This means that when you move from one version of Kubernetes to the next version, there is no guarantee that there will be API compatibility. So if you write an application or a Helm chart, and we'll discuss what those are, that works for, say, Kubernetes version 1.16, which is a somewhat older version of Kubernetes, there's no guarantee that it'll run on 1.17 or 1.18. So what you need to do is plan for that. You say, okay, that's not something that's going to slow me down. I will plan for that in my architecture. I will plan to be able to support simultaneously multiple different versions of Kubernetes. And then I'll be able to deploy my applications into that version of Kubernetes that works for this particular application. And of course, over time, I will continue to evolve up into the latest version of Kubernetes, but I don't want that to slow down my ability to get my applications into production. So this is something very key to look at as you plan out your strategy. Secondly, Kubernetes is an incredibly rich ecosystem. It has plugins for how to interface to container storage, how to deal with your networking, and so forth. But these can be really challenging for the organization that does not have deep Kubernetes knowledge. So when you look at a platform or a tool that's deploying Kubernetes for you, look at for one that's opinionated, one that will select a reasonably decent container storage interface for you and will come with a defined container network interface. This will just make it much quicker for you to adopt Kubernetes in your environment. Now, of course, as you gain knowledge and as you gain institutional information about how you want to craft your network, you can certainly replace the default CNI with a CNI that may be more suitable for your security and your network environment. But don't try to boil the ocean all at once. Take it in stages. Go with a common supported container network interface and storage interface from whatever vendor or provider that's giving you the Kubernetes solution. And finally, particularly for enterprises where there is security, which is pretty much every enterprise out there, make sure that your vendor or your tool that's doing your Kubernetes deployment can integrate with your existing authorization and authentication system, such as Active Directory or LDAP. Make sure it integrates with Kerberos. Many of you probably out there have existing data lakes, and if you were using Cloudera or Hortonworks or Hadoop in general, those are large collections of HDFS formatted data, probably protected by something like Kerberos doing maybe transparent data encryption. how do I make all that work with my containerized applications? Make sure that there is an easy way so you don't have to do the work of cross-realm certification for Kerberos and somehow shoehorn that into a Kubernetes application. Make sure the vendor does that for you. Similarly, if you already have a single sign-on substrate within your organization, which most enterprises do. Typically, they use what's called SAML 2.0 for the API. Make sure that when you're deploying your Kubernetes clusters, it can integrate with your single sign-on so that your internal customers have the best usage experience. They only want to provide their credentials once. They don't want to have to provide them multiple times as they deploy applications within Kubernetes. So these are some of the very basic things to look out for when you're developing your platform. You take this checklist and you write this down. You say, okay, here are the things that match up. Here I'm handling these, so I'm sure that I will reduce my risk as I roll out my Kubernetes infrastructure. Now let's talk about day 2 activities. So we got the Kubernetes installed, we got our applications running, everything's great, but now it's time to update. Wow, how do I roll out an update? Make sure you plan for that ahead of time. There's always going to be new Kubernetes software versions coming out. How do I roll out those with the minimal amount of downtime? I don't want to impact my running applications. So you need to plan for that way up front so you're not surprised by it later on. Similarly, how do I handle a hardware failure? Maybe I have 5 racks of servers in my data center. I have a connection to Amazon or Azure or Google for my public cloud solutions. And then all of a sudden I lose a NIC card. How do I handle that? How do I recover? I lose a rack of servers, or there's a power glitch that takes out a couple of servers in my cluster. How do I ride through those? How do I replace them? How do I make sure that my hardware can be updated and upgraded going forward? These are all things that you want your platform to handle for you with a lot of automation, because you want to reduce and minimize your downtime. So plan ahead for day 2 activities. Now, what I frequently get a call, hey, why don't I just run everything in virtual machines, and then that will give me this abstraction. Hardware failures will be hidden from me because I'm running my containers in VMs. Now, while that is a reasonable solution, it is something you can go ahead and do. We recommend not doing that. We recommend putting your Kubernetes and your containers on bare metal for performance reasons. But you want to make sure that you can handle noisy neighbor and reduce the attack plane. So this means that you want to still be able to control the application running in one container from impacting the performance of another container. So your vendor of Kubernetes can do that for you, but you'll have to make sure that that's the case. And finally, as we've spoken about a number of times today, make sure that the deployment supports cloud native applications as well as legacy or non-cloud native applications. So it's a plug for the HP Container Platform. HP provides a fully integrated solution, works across on-premise, public cloud, edge nodes, integrates with the hybrid cloud, full support for cloud native and non-cloud native applications. Obviously, the value of this to the enterprise is to bring speed and efficiency to all your applications, not just the cloud native ones. We drive down the costs by running containers on bare metal. And so we also integrate with every enterprise security system. We've been doing this for years. Integrate with Active Directory, LDAP, Kerberos, SAML, single sign-on, the whole bucket. Had a lot of experience integrating with many different markets, vertical markets, and customers. So we have a lot of knowledge on how to do this and make it really easy to deploy your applications anywhere. You build them once, you define that Docker container, you can then deploy it on your Kubernetes clusters on-premise, public cloud, or a private cloud, as Bob pointed out. When we say cloud native, it's not necessarily the public cloud, so you can run it on a private cloud as well, or an edge node. Now let's just talk quickly about application patterns, since we're talking about application modernization in this webinar today. One typical, very common application pattern is just write the application to talk to the Kubernetes API itself. This makes it really trivial. And some applications have actually done that. Best example is Spark. So you can get a version of the Spark machine learning, deep learning, distributed application that already knows about Kubernetes. And so it will communicate with your Kubernetes server and scale up and scale down as necessary. No other work required. This is a great application. Unfortunately, there's not too many of those. More likely, you'll see something like a cloud native application. This is where a Helm chart or a CRD, CRD stands for custom resource definition, has been written for a particular application. Then if you have a Kubernetes cluster, this application can be deployed on that cluster, and then Kubernetes will effectively manage it for you. These are things like the Kafka, a Confluent operator. Elasticsearch also has an operator. These are very straightforward. Now we have the last kind of the troubling problem child for applications on containers, and this is the legacy application. Okay, how do we run these things? You can run them in something like a KubeVirt. KubeVirt is a tool which effectively just launches a VM on top of a container. Kind of a heavyweight solution, but it is something that will work. Or you can kind of re-architect it, or you can try to use the stateful solutions of the Kubernetes platform. In the next slide, I'll talk about that. But things like Helm, and there's also an open source project known as KubeDirector, which goes further than Helm for deploying legacy applications. So we have these things called stateful sets. These are a standard pattern within Kubernetes. They allow persistence of IP address, unique network information, ordering, and so forth. And they're nice, but they're not really sufficient for running an application. A stateful legacy application has data persistence outside of what's controlled by the stateful set. So what was added was a thing called persistent volumes. This is the ability for Kubernetes to associate a unit of storage that has a lifespan beyond that of the container, and then associate it with the container as needed when the container comes up. Now, these are great tools, and together stateful sets and persistent volumes go a long way, but they're still not, they don't handle all legacy applications. In particular, what to watch out for is if your legacy application tends to have configuration information or persistent data in what's known as root storage, that root storage is not persisted in a container with your regular persistent volume. So you have to have a solution. How do I manage that persistent storage for the root storage of my container so it's not lost when my container exits? So Helm charts we spoke about, and these are great. These are ways to deploy complex applications on Kubernetes, but they're pretty much a fire and forget methodology. It will help you to deploy the application, but it won't help you with any day two activities. Doesn't help you update, doesn't help you expand or contract the cluster. Solutions for that require this things called operators, CRDs, as I mentioned a moment ago. But these require a fairly sophisticated developer. This requires a programmer who understands the Go language, who has intimate knowledge of each of the applications that they want to use, and then also a significantly deep knowledge of the Kubernetes API. They can then develop and design this Go code, which will control the deployment of the application. This is okay for some applications, but it's not great for customers who have applications that they need to run and they don't have the expertise to write these CRDs. So what do we want to do? We want to provide a better way. We don't want to create a new operator. That's a pretty heavyweight solution. And we don't want to do one for each new application. So how can we do this without radically re-architecting the application itself? Or so we could do it with KubeVirt, but then with KubeVirt we're incurring a significant amount of performance overhead penalty. Well, there's this other thing which I showed earlier, which is a KubeDirector app, and this is what the HP container platform uses. It is an open source tool available on Apache open source GitHub, and what it will do is it will control a legacy application. It will manage the persistence of the local storage. It will bring up the application, then handle day two behavior. So upgrade, scalability, both contraction and expansion, and it will do this in a fashion that is application neutral. So all that has to happen is that the user of the application will populate a YAML file, which is just an ASCII text file, provide that YAML file to the Cube Director CRD, and then the Cube Director app itself will manage the execution and deployment of that clustered application on Kubernetes. Makes it really easy to go ahead and do that. So as you look at your options for running your legacy applications, you want to consider something like Cube Director, you might want to consider KubeVirt and so forth. But these are things I wanted to point out to you as we consider our journey to app modernization. So at this point, I'd like to turn it back to David for our wrap up.
Excellent presentation, Tom and Bob, both. Now it's time for Q&A. We just have a few minutes left for Q&A. While we do that, I'm going to bring up this poll question for you out there in the audience, and it says, what additional information would you like about the HPE container platform that you learned about on this event today? So I'll just leave that up. Select the option that corresponds to you. You can actually select multiple if you would like. I also want to remind everyone that the slides from today's event are available there in the Handouts tab for you to download. So make sure you download those before you go. All right, so let's see. First question that came in, we just have a few minutes. Maybe this one's for you, Tom. How do I decide if I want to run my legacy applications in VMs or containers?
Okay, it's a great question. Very a common question for people as they go down this journey of app modernization. What I would say is, how much engineering resources do you have? If you have a legacy application, let's take a look at it. Is it how many different services are working together, and can those services be easily broken apart into microservices? If they can, then that's a really good candidate for re-architecting it into a containerized solution. If you have a legacy app that is really monolithic, has deep knowledge about perhaps what's called the proc structure within the operating system itself, so there's a tight welding of the application with the underlying operating system, that's the one I would leave on a virtual machine. So that at a very high level, that's the kind of the first split I would use. We could certainly go into more detail, but in the essence of time or sake of time, I'll just confine the answer to that.
Okay. All right. Excellent. And this one for you, Bob, this one's similar but different. That is, how do I decide where to run my containers, on premises or in the cloud?
Yeah, no, that's a great question, and a lot of that's going to come down to, I think, where the data is. So there's a lot of gravity that data has. So if a lot of the predominantly your information, the resources you have to pull from are in the cloud, then I would expect to see organizations maybe pulling from there. If they're on premises, then likewise on premises. The one thing I will comment on is that what we've seen in our research when we ask organizations about this, the newer companies, those, as I mentioned earlier, the digital native 10 years or less, those are the ones who tend to have more of a cloud first, cloud always policy versus the existing organizations, which are much more, they'll make, I think the majority of them now make a decision. They'll look at the application, look at where the data is, and decide where to have it deployed.
Okay. Okay. Excellent. And then this is an interesting question that just came in. They're asking, what's the best way to approach converting legacy applications to microservices? Any suggestions from either one of you on that?
Sure. I mean, there are a number of tools out there today which will process the source code of the legacy application and attempt to generate frameworks, which then require some developer to go in and refine. That's a way, kind of a first step if you want to begin the effort of re-architecting your legacy application. I would suggest that. Bob, do you have any other insight here?
Yeah, no, I think that's great. I mean, obviously, there's a lot of organizations. I've heard stories of organizations refactoring their applications, and it was hundreds of engineers over several years. So it really comes down to, there's that cost benefit analysis that goes into, when you've got a legacy app, are you going to be refactoring it, or are you just going to start new? I think is some of the decision process that needs to be made.
Okay. Okay. Excellent. Excellent. All right. Well, it looks like we're running out of time here in our time slot. There's a number of questions we won't have time to get back to. I apologize for that, but we'll have to do that after the event. Before we go, I want to give the final question to you, Tom. What should people do to get started? What do you recommend?
I mean, in terms of reaching out to HP, I would say reach out to your sales rep if you already have a relationship with Hewlett Packard Enterprise. If not, please go to the website and do a search on the container platform, and then that would provide you the links to the information that we've described today in this webinar and help you move on your journey.
Excellent, excellent. And both Bob and Tom have so generously provided their contact information there in the slide deck. You can, again, download that in the Handouts tab. Before we go, I want to award the Amazon $300 gift card that's going to Jay Rogers of North Carolina. Congratulations, Jay Rogers. And again, thank you to Bob and Tom both for your expert presentations today. Really appreciate it.
You're welcome. Thank you.
Yep. Thanks, David.
And thank you to our audience for joining us on this event today. I learned so much about containers, Kubernetes, and container platforms, and with some great advice for the future. So thank you to HPE for supporting today's event, and thank you to our audience for joining. Have a great day. We'll see you next time.